In this lesson we're going to take a look at how to draw what's called an orbital diagram, and really it's just a visual way of representing an electron configuration. So let's start by reviewing electron configurations. Here we have nitrogen. It has 7 total electrons. That's its atomic number. So we would place these starting with the first energy shell. 1s has 2 electrons. 2s has 2 electrons. Okay, then comes 2p, and remember the 2p sublevel can hold up to 6. But do we have 6 electrons left to place? We have 2, 4, and we need to get to 7, so that means we only have 3 electrons left to place. Now, in order to draw this, basically what we're going to do is we're going to draw the electrons within those sublevels, and we're going to depict them as arrows. So 1s can hold 2 electrons, and that means it basically has one spherical orbital that can hold up to 2 electrons. And so I'm going to draw them like this. One arrow is pointing up and one arrow is pointing down, and that just signifies that they're spinning in opposite directions. It doesn't mean they're orbiting, like spinning around the nucleus in opposite ways, but electron spin is something fairly complicated. We need to get into a higher level of chemistry to really identify and understand what that means. Basically, if we have one electron spinning in a positive direction, we can have one spinning in a negative direction. We'll just look at it that way. Okay. Our next sublevel is 2s, and once again it's an s, so it can only have one orbital that can hold up to 2 electrons. Okay. Now when we get to the 2p, based on its shape, it can have 3 orbitals, so we're going to draw 3 boxes. Okay. And those boxes just represent different orbitals, and it can hold up to 6 electrons, but we've only got 3 electrons. Okay. Now what a lot of people will do is this, and don't write this down, this is something I'm showing you that's actually incorrect. Okay. They place those 3 electrons just like that. However, there's a rule called Hund's rule. Hund's rule states that as long as there's an open orbital, an electron will occupy that orbital before it will double up with another electron. So what that means for us in orbital diagrams is we need to start by putting at least 1 electron in each orbital. And then if need be, we go back and start doubling up in those orbitals. But in this case, we have 2 electrons here, 2 here, 3 here. There's all 7 of our electrons, and that's what we call an orbital diagram.